So this is from the 2016 BC exam. Question number 2, is calculator active? So we need a calculator for this, and I've classified it as type 8 because it is parametric stuff. They give you a parametric function here, x of t, y of t. Some of the content might be classified as type 2, but I stuck it under type 8 because I think all of it you have to do in parametric mode. So part A says find the position at time 3. So to find the position, we need both an x-coordinate and a y-coordinate. And the y-coordinate is pretty easy to pull because they give us the graph of y. So y of 3, looking at the graph, is at -1/2. The x-coordinate actually requires calculus. So the x-coordinate at time 3 is equal to my starting position plus the accumulation from 0 to 3 of the rate of change of x. And we are given the rate of change of x, so this is where our calculus rests in. At time 0, x of 0 is 5, and 0 to 3, x prime of t is the dx dt there given to us. And this is where we turn to a calculator and type this into the calculator. All of you are equipped to evaluate from your calculator, so I'm not going to show you in the video how to do it. But if you typed it into a calculator, you'd get 9.377035. So the x position is approximately 14.377. So our position, xy, is 14.377 comma -1/2. This is worth 3 points. 1 point if you did the integral of the rate of change for x, 1 point if you included the initial condition, and then 1 point for the final answer, for a total of 3 points in part A. Moving on to part B, find the slope of the line tangent to the graph at t equals 3. So part B is asking us to find dy dx when the time is 3. Now our function is not expressed as a function y equals f of x. We have it in parametric mode, so we have to do dy dt over dx dt when t equals 3. So dy dt is the slope of the y graph at time 3. And if we go to the y graph and the slope of this graph is rise a half, run 1, rise a half, run 1, or as my students prefer, rise 1, run 2. So the slope of the y graph at time 3 is 1/2. The slope of the x graph is a matter of plugging 3 into our dx dt. So if we wrote 3 squared plus sine of 3 times 3 squared, we have a numerically accurate answer right here, and it gets you the credit. But if you went through the process of actually simplifying this down, it's probably about 0.05. Since the key is missing a digit here, I suspect it's like 0 something or other after that. But this is worth 1 point. Did you do the work that supports the answer? +1. On to part C. Part C is asking for the speed of the particle at time 3. In the world of parametric calculus, speed is the square root of dx dt squared plus dy dt squared. And if you integrated that with respect to t, you would get the arc length, or total distance traveled. Either way. So here we want to evaluate this at time 3. So we're going to do dx dt of 3, which is 3 squared plus sine of 27, quantity squared. And then dy dt, we've established, was at time 3, positive 1/2, rise 1, run 2. So 1/2 squared. Grabbing a calculator and simplifying it, since it is calculator active, though this is good enough for the answer, we get a value of approximately 9.969, or if you truncate rather than round, 9.968. This is worth 2 points. 1 point comes from an expression for speed. And the second point comes from correctly evaluating at time 3.
All right, Sean White going to need an incredible run to bring home the gold here. He starts off with a 1080 kickity flip stick McTwist bit, flawlessly executed. His next trick is a 720 double Mac attack with cheese, nails it. Let's see if he lands the 12-piece McNuggets. Nice. All right, and his second to last trick will be his most difficult. A Walmart McFlippity McFit McBitch with no tomato lands it. And his final trick, a skibbity scoobity floppy flop oh, nails it. Sean White with the perfect.
Okay, moving on to part D. Speed, we learned in part C, speed is this expression, and total distance we also talked about in part C as being the integral of this. Now, if we do that on the interval 0 to 2, our dy dt is different between 0, 1 as it is 1, 2. So we actually need to set up two different integrals because our dy dt changes based on those two intervals. So in the first case, dx dt squared, and the slope of y on that interval 0 to 1 is down 2 over 1, or down 1 over half. Either way, the slope is negative 2 on that first interval. On the second interval, from 1 to 2, our dy dt has a slope of 0. So the dx dt gets squared plus our dy dt is 0. This is an operation you can type into your calculator. And if we evaluate this expression on the calculator, we get roughly 2.2378. And if we evaluate the second one on the calculator, we get roughly 2.1120. Adding those two together, 4.350 if you round, or if you truncate, 4.349. This is worth 3 points. One is the expression for distance, one is the integrals, and one is the answer. So I'm going to kind of lump this together because I think that supports the expression for distance. The actual key provided by the College Board, you can see distance, they showed like this, but then because of that oddity occurring at 1, they split it into two separate integrals. So.
Thanks so much for watching. Make sure to subscribe, smash the like button. Let's try to get to 10 likes this video. It was a really good one.